Hello everyone, my name is Brian Campbell and I'm a NASA Senior Earth Science Outreach Specialist based at the NASA Wallops Flight Facility in Wallops Island, Virginia in the United States. Today I'm going to talk to you about measuring and observing tree height with NASA ICESat-2, the GLOBE program, and the Open Altimetry online tool. Before we get into the online tool, let's talk a little bit about tree height and why it's important. Did you know that tree height is the most widely used indicator of an ecosystem's ability to grow trees? Did you also know that tree height observations are such a vital measurement because it helps researchers understand how much carbon is being pulled in from the atmosphere by trees, okay, and being stored by trees. Think of a really, really large tree with a large trunk and a large branches and lots of leaves. That tree can take in a lot of carbon dioxide from the atmosphere as opposed to, say, a sapling. Tree height is one of those things that can really help us understand this gain or loss of biomass, which can help us understand further the calculations of carbon that trees and forests take in from or release into the atmosphere. There's several NASA missions out there that look at tree height from space. And the one we're going to focus on today is ICESat-2, the Ice, Cloud, and Land Elevation Satellite 2. Yes, since its name is ICESat-2, it focuses on the climate change science of looking at the melting of the ice sheets in Greenland and Antarctica, looking at glacial melt, glacial retreat, but also because it's an onboard laser altimeter on ICESat-2, it can measure the height of many other things, like, for instance, trees and forests. It can look at the height of buildings and bodies of water like the oceans and lakes and rivers. So lots of other things. If it has elevation on our planet, ICESat-2 will be able to measure it. So how does it do that? ICESat-2 uses what's called LiDAR, or light detection and ranging. And most of you probably know it's an active remote sensing technology, basically the laser version of radar. It uses pulses of laser light to measure the 3D structure and height of objects on Earth. So basically what's happening is we're calculating the time it takes the laser pulse to leave the satellite, hit the Earth's surface, and come back to the satellite. And with that time, we can figure out how tall things are on our planet. So let's talk a little bit more about trees and tree height. There's a program that I work with and that is NASA funded called the Global Learning and Observations to Benefit the Environment Program, or GLOBE for short. Through the GLOBE program, there are 123 participating countries involved. The program was started in 1995 by Al Gore. And so we're in the 25th year of the GLOBE program, and there are almost 200 million observations taken by students, educators, and citizen scientists in those 25 years. Now, what do I mean by measurements? Well, the GLOBE program was designed for, first of all, for students to go out around the world and take observations like air temperature and precipitation and soil moisture, and looking at soil characterization, looking at tree height, all different types of biometry like land cover and green up, green down, and seasonality. It was all designed for students to take these observations locally, share them with the rest of the world so everyone can understand what's happening locally to better understand the global picture of how our planet is responding to change. With tree height was originally part of the biometry protocol and still is for students and educators, but we've advanced it a little bit into citizen science. So here, what you're seeing here is there's two ways through the GLOBE program that you can measure tree height. One is building a handheld clinometer with just paper and some simple tools. Another way is to use the NASA Globe Observer Trees tool for citizen science, which uses your mobile phone's built-in magnetometer to measure the angles to the base of a tree and the top of the tree, and then you count the number of steps you take as you walk to the base of the tree. The phone is programmed with some trigonometry in this NASA Globe Observer Trees tool to get you the height of the tree that you're observing. Now, one way we like to try to maximize accuracy of the tree height coming from the students, educators, and citizen scientists is to have them do a handheld clinometer measurement of tree height, and then also use the citizen science trees tool on the NASA Globe Observer to take one as well, and then do a comparison. If you see that they are very close, then you did a great job and things seem to be working out perfectly. If you notice that they're pretty far off, if you maybe you get with the clinometer the tree is 10 feet and with the app you get the tree is 22 feet, then you know something's wrong. One of your calculations is wrong. So you can go and then try it again, and basically practice makes perfect. It's like the scientific method. You got to do it over and over again to get better at it and increase that accuracy with the data. But with the GLOBE program, as you can see here, we have observations coming from all over the world. As I mentioned, there's 123 participating countries. What you're seeing here on this graphic is the GLOBE visualization system. It's a database where all the GLOBE data goes. This just happens to be all the tree height data that has come through the GLOBE program that has been submitted to the GLOBE database since 1995. There are over 40,000 tree height observations from over 13,000 global locations. That's a lot of data, but for research over a long period of time, that is not enough. We need more data, and hopefully some of you listening to this, or if not all of you, will go out and take some tree height measurements with the GLOBE program. So this visualization system here allows you to go in and zoom into a particular area that you're interested in. Here I zoomed into a particular tree, and when I zoom in, I get some specific information. I get the time and date it was observed, what the tree height is, and what the elevation is on the ground at that location. And then also, I get the geographic coordinates. I get the latitude and longitude, and once again, I get the elevation as well, and the location source. This happens to be GPS. So all this information is available on the GLOBE database. It's really amazing. There's lots of it, as I mentioned, with all the different protocols, the 50 plus protocols on the GLOBE program. There's almost 200 million observations in 25 years. Tree height, we're trying to get more of, but I should mention also that the tree height observations started in 1995, but only became part of the NASA Globe Observer Citizen Science Trees tool on March 26, 2019. And we've had almost 25,000 just from the app since March 26th of 2019. So the numbers are coming in fast and furious, and we're so happy for that. And so are the researchers that I work with every day. They want that data density as part of these measurements. Now, I mentioned earlier something called the Open Altimetry online tool. So this is created by NSIDC, and it's a way that you can go in and visualize ICESat data, and what we're talking about now is ICESat-2 data. So you can look at data all around the world. You can look at surface elevations, the elevations of the ice, but we're going to focus on trees. So if we go into the program a little bit, we're going to get a map that looks like this. These are all ICESat-2 orbit tracks, and the colored dots you see, those are all photons, okay? So I found one that hit my area on my property in Maryland, and I'll show you what I did with it. But when I go into it, when I look at it, I can look at the photon data specifically, and I can look at each individual tree canopy height that was in that location, basically where that 14-meter diameter photon hit the Earth and then bounced back to the satellite, and then the data came back to Earth. So that's what we're looking at here. So on this map here, this is a map of my location, and that little grayed out box there is just a sample that I took, and I sampled these photons. And what you're going to look at is a photon towards the bottom of that square, okay? So it's the third one up from the bottom, and it gives you the latitude and longitude on Open Altimetry. And what I did was, where you see the NASA Globe Trees Tool data and land cover data, this is where I did some comparisons. I took observations with the Citizen Science tool, and I got tree height data and land cover data. And then I compared it to Open Altimetry. And you can see here, the ICESat-2 data and the NASA Globe Observer data match up really closely, and that's a success. You can see here, there's the tree height specifically, and then that's the location of where the photon hit. So perfect matchup. Now, if you want more information, here's some associated links and contact information, and feel free to contact me at brian.a.campbell@nasa.gov. Thanks so much.